G'day YouTube, my name's Rob. I'm an amateur radio operator from Australia that happens to have an interest in hacking. The day is Saturday, it is 10:44 AM and it is the 7th of January 2023. I'm in my wife's home beauty salon and we are going to make a DECT voice traffic decoding video. I'm going to preface this by saying that I'm not here to teach anybody how to listen to encrypted or secured DECT voice traffic. I'm only going to do this video for the purposes of showing you how to make sure your own equipment at home, whether it be telephones or baby monitors, are secure and no one is listening to your private conversations when you're speaking privately inside your home. My two DECT videos have been getting a lot of interest lately, and someone by the name of Craig Daniels asked if I could go into more detail. So here we go. So everybody knows what DECT is, don't we? It's a standard for short-range digital voice communications. Its main use is cordless telephones, and then other uses are for parents to monitor their newborn child with baby monitors. There's 10 channels, and it's TDMA. And as you can see, a lot of countries all use different frequencies, but it's all in the microwave, upper microwave band. I'm in Australia, so my frequency is 1880 to 1900, but this particular DECT item I'm going to showcase is actually from America, and it's not licensed to use in Australia. So, but just for purposes of experimentation, I'm going to make a video using this, so we'll keep it short. So this is the product I'm using. They're unencrypted. That's the significance of these items, so that's why it's fun to play around with these. They're relatively cheap and abundant on eBay. I think I got these for like less than 30 American dollars, including shipping or something, secondhand in the box, which is pretty nice. They're made for the US and Canadian market. So if you are using these outside of Canada and the US, it may be illegal to do so. So make sure you're going to keep them in a Faraday cage or RF shielded environment. Next thing we need for this is an SDR. The tools support the HackRF already, so that's why I've just stick with the HackRF, because I've had one for quite some time now and I love it. I use it all the time. It's quite expensive. It's transmit capable, which is fun. It's been around for a while now. I think it's considered to be maybe the first affordable TX capable SDR, I believe. Because it's been around for so long, it's probably got the best support for the purposes of hacking and stuff. A lot of tools are made to support the HackRF, which is really nice. The antenna I'm using for it is just the one that sometimes comes with the HackRF and sometimes doesn't. I think you maybe have to option it when you do the purchase. But when you're doing short range tabletop experimentations, antenna doesn't really matter. Just try and plug anything into it because it's such short range. Don't get hung up on what antenna to use. I just use this one and it works perfectly. The laptop I'm using is a Asus ZenBook Flip. It has an 8th gen i7 in it. So because of the high DECT data rate, you need to have a very powerful computer. And yeah, it's got a mobile Core i7 in it, which does the job fine. So the software we need to use is Linux. Can't do this in Windows. And I wouldn't recommend doing it in a virtual machine either, because it never worked properly for me in a virtual machine. DragonOS is made by SEMA Executor. Go and check out his channel on YouTube. It's absolutely amazing. I love everything that dude does. And he has good DECT tutorial videos as well, probably better than mine, so go and check him out. He's awesome. You need to run this in bare metal, right? So when I say bare metal, I mean we need to boot it from a USB, so it's running natively on your computer. If you try and do it in a VM, I could never get it working properly. If you use it in a VM, you get choppy audio and it just sounds awful. It's still fully readable, so if you're using it for surveillance purposes, you could still make out what the person's saying. But if you want really nice, smooth, non-choppy DECT audio, you need to run this on bare metal. So for that, I purchased one of these. So at the time of purchasing this, it was apparently claimed to be the fastest USB stick on the market. It doesn't matter. If you want DragonOS to run good, boot fast and run well and stuff like that, you need a fast USB stick. But I've run it from USB 2.0 sticks, and aside from booting slow, everything else works fine. So it doesn't really matter. I just thought I'd show you what I'm running it on. And how to make a bootable DragonOS installation, I use this tutorial here. And what's nice about this tutorial is it uses Lubuntu as the example, which is what DragonOS is made from. So all the screenshots look identical to DragonOS, and it's really easy to follow. It's a great tutorial. So I just did that. So that's really nice. And the other things we need, which are already pre-installed in DragonOS, is GNU Radio. So I could never install this by myself, ever. I'm not very good with Linux, surprisingly. I could never get this to install and run. So this is basically what you need for a lot of radio hacking stuff, GNU Radio and Linux. So that's already turnkey, ready to go in DragonOS. And the last thing you need in terms of software is gnuradio-companion 2, which is installed and running and working in DragonOS Linux already. So that's all really nice. So I'm going to set the scene and get some stuff set up and running. So first thing we need to do to ensure that DECT is going to get decoded smoothly is to run something called Vocal Profile. I don't really know the specifics of this, but it's some kind of CPU instruction set maybe that's optimized for processing stuff in GNU Radio. I really don't know. So I always run this. It's already been run because it takes some time to run it. So that's already done. And the next thing we need to do is, I do this for all of my radio stuff, is set the CPU scaling governor to performance. And you can do that with this command right here. So that's already run, so we won't have to worry about that. And I'll just set the scene hardware wise now. I have my laptop powered on right now, obviously, because I'm recording this video. It's booted into DragonOS by my bootable USB. Vocal Profile and CPU performance scaling commands are run. The HackRF is plugged in, and the parent and baby units of the baby monitor are plugged into AC power and switched on. So now what we need to do is run gnuradio-companion and open up the gnuradio-companion 2 HackRF flowchart by using this command in DragonOS. So we just press enter on that, and then this window will show up. Now this is a this is called a flowchart, and this is all like different things, filters and other things which are required to decode DECT. Again, I don't really know the specifics of this. I'm slowly learning about all this kind of stuff, but beyond, for all intents and purposes right now, it's way beyond my knowledge how all this stuff works. So a bit of explanation is, so to start this, you press this little play button up here at the top. So we'll hit that, and this window will open now. This is called the top block. So yeah, some explanation is required for this. Make sure you set your gain correctly too, because if you're just performing tabletop experiments, right, where the antennas and the baby monitor are like really close together, you're going to splatter the front end if you have too much gain. So make sure your gains are set correctly. For desktop, I think 24 and 24 works fine for me. tabletop experiment, sorry, and yeah, you don't need your low noise amplifier for short range experiments. So first thing I need to explain is the carrier number. So this is the channel, right? Each DCT region has 10 channels over, not sure, maybe like, I can't remember how much it is. Maybe it's like 8 megahertz or something. I'm not sure. In Australia, I notice a lot of my DCT equipment at my house operates anywhere from 0 to 8. But in America, sorry, not in America, but my baby monitors from America usually hover between like 21 and 24, roughly. So I've found mine already, which was hovering on 20, hovering around 23. Hang on, I'll just sort this out. Sorry, you probably heard the baby monitoring audio coming through then. So yeah, I've already found my carrier frequency, which is 23. So the next thing I need to explain is the part. So generally the parts are 0 and 1, but sometimes they can be like 0 and 2 or 1 and 2. Doesn't really matter. It's just the allocation that it's given. It's a base station and the base station and the other part a number. It doesn't really matter. So a bit of explanation is required for this. RFP stands for radio fixed part, and that's generally the base station. So when I say base station, I mean like the cradle that the handset sits in on a cordless phone, or in this case it's the parent part of the baby monitors, right? So the part that you would carry on you, it may be battery powered or plugged in, which will receive the audio from the baby monitoring part, which will be mounted inside close to where someone's toddler could be potentially. So, and then the portable part in terms of cordless phones is the actual handset, and portable part in this instance is the part which will be mounted inside a bedroom potentially listening. So yeah, that's that. And yeah, that's really all the explanation you need. So this should be all ready to go. So what I'll do is I will mute my microphone, and then I will tune into the radio fixed part of the baby monitoring system, and then hopefully you'll be able to hear my audio coming through. Hello, I believe this is me talking through the baby monitor now. And just to prove that it is coming through the baby monitors, I've just got my volume control window open, and you can see that Python 3.8 is the current software playing the audio. So yeah, that is my voice now coming through the baby monitor and then being decoded by gnuradio-companion and the HackRF. So yeah, that's really cool. Sometimes it's a little bit delayed as well, but most of the time I found that it's close enough to be considered real time. So sometimes the audio jumps around, and I just fix that by going to configuration and then just changing these audio devices to something else, and then going back to the original audio device, and then this will stop blinking and the audio will stop skipping. But for the most part, I believe it is playing clearly now, so I'm just going to leave that as is. It's great that it worked the first time when I'm trying to make a YouTube video. Cool. So yeah, obviously this is a massive privacy risk, right? How many people have these things mounted inside their homes, and with the right equipment, somebody could potentially be listening to what you are talking about inside your house, private conversations. So the reason I do DECT videos is not so I can show you how to potentially perform surveillance on a target or eavesdrop on your neighbors or anything like this. I make these videos to show you that these things aren't secure. and people are probably potentially listening to your private conversations inside your house. So I like to make these videos and show you that with the right equipment, you can ensure that your own equipment at home is secure, and that the private conversations you're having inside your home are not being eavesdropped upon by somebody potentially. So yeah, so anyway, that is a more in-depth video about DECT decoding. If you want any other videos for me to deep dive into other topics I've covered in the past, potentially not more as in-depth as you'd like, just comment or whatever. Send me you can get my email address easily because I'm a ham radio operator, so yeah, I'm sure you'll be able to find that. You can email me. And yeah, thanks for all the support that you guys have given me now over the last couple of months when I've been growing my YouTube channel. It's really appreciative, and yeah, hopefully I'll find some other cool stuff to churn out for you guys. So that's all I have in terms of DECT, so we will turn this off now. Just before I go, I'll just show you that skipping audio issue. So I'll just to here, and then you can see that that's not blinking anymore and the audio is not choppy. So that's how you fix that. Anyway, no worries. Thanks very much. Catch you all later. Bye.